Hello everybody, welcome back. My name's Jace. This channel is about my efforts to build an N-gauge railway, and today's part 2 of the control panel build. It's all about diodes and LEDs and resistors and things. Now, if you've watched part 1, you'll know that I built this little control panel or fascia, and if you haven't seen that video, might be an idea. Pop back, watch that one, and then come back and watch this one. If you did, you'll know that I fed the LEDs and switches through, and that evening I spent a couple of hours of my life putting wire numbers on the appropriate ones, and that's going to make it a lot easier later. But today I want to show you how I'm intending on building some more of the actual control panel and how I'm going to lay things out. So this is what I've come up with so far. You need to imagine that this is a net of a box. So these sides would be up here and the panel would be on the top like that. So this would be the enclosure laying on its back. I probably will put a front on it and a bottom at some point, but for now I need the back and the two sides so that I can start mounting things to them. And I'm happy to have a deeper box and say normal, because I've got a deep baseboard, and what that's going to allow is cables to come out the bottom of this and underneath the baseboard. Now, in a previous video I said I was going to run all the wiring to some blocks here that could be disconnected so that I could have the control panel on this side of the board or this side. I've changed my mind on that. What I'm going to do now is bring the wiring loom along and make it long enough that it will reach this side or this side of the board and connect to the control panel with the connector blocks that I was going to put on the board. And so I've been kind of laying things out, seeing how I'd like to do it, and I've ordered some connectors that are twice as big as these ones. So these are 12 pin, so there'll be 24 pin, so there'll be two like this. That's going to be all the wiring coming from the board into the control panel for the point work. So there's 12 points. You've got 4 wires per point. So we've got 48 points. And we'll have 2 blocks of 24. So that's 48. So that'll work quite nicely. Over here, the second half of this block of 24, so 12 wires, these will be the brown wires coming in, 2 resistors, and then to all the LEDs on the board. I'll say all, not quite all, and I'll explain, I'll come back to that. This block here will be for the lights, so anything to do with the lighting circuit will come down and through here. This is going to be a DCC bus, so I'll split it, one side positive, 3 terminals positive and 3 negative, and then I can wire my LEDs into there too. And this one here is going to be DCC power, DC power, and DC power out to the turntable motor. And I'll probably leave a good 2 or 3 terminals spare in between DCC and DC, just to try and avoid confusion as much as possible. We're going to have the potentiometer for the turntable, maybe somewhere like that, maybe somewhere over here, and then I've got to drill a hole in there, and then that bit will stick up through the hole with a knob on it that I can twiddle. So this is kind of how I'm thinking, and I'm thinking I can wire it up on here as that is, and then fold the sides up and glue and tack them together, pin them together. These bits of wood do need to be cut down a little bit smaller because I forgot to allow for the thickness of the front and back. I just cut them the same width as this. So yeah, that's what I'm thinking. Now to make these LEDs work, each point has two rows coming out of it, obviously. So if I flick the point to send a train down this line, I want this light to light up. And if I send one down this line, I want this light to light up and that one to go off, indicating a safe route, so to speak. Now in the DCC concept drawing, they show us how to do this. So terminal 3 out of the point motor is to the frog, and so this switches polarity, obviously, this terminal. So we can wire our LEDs like this. Now an LED has a diode. The LEDs I've bought already have a diode in them, and that's what this symbol here is. So the best way to think of a diode is an electrical one-way valve. It will only allow power through in the direction of the arrow. It won't allow power through the solid line there. So power can come this way into the LED and then out and through a resistor to the switch, and vice versa. When the point motor switches to the other side, this polarity changes and therefore power can come out of the point motor through the resistor, through the LED and diode, and back to the DCC bus. A resistor is basically, it restricts the power. So if you think of a hose pipe and you kink it, you get less water out at the end, and that's pretty much what a resistor's doing. So a diode is a one-way valve for electric, and a resistor is a restriction, as the name would suggest, and it therefore allows less power through. And you get different powered resistors for different things. Now, I'm going to be using 12 volt LEDs, 12 volt DC LEDs. The DCC bus on my layout is around 15 volts. And therefore, I've got to reduce the power from 15 volts to 12 volts through a resistor. And there's a resistor. Tiny little thing. Now I did the calculations for my layout. This is not a value of resistor that you should just necessarily fit to your layout. And using Ohm's law and some calculators online, and in the end just my phone and a calculator, I came up with I need resistors of 560 ohms. I'm not trying to drop the power very much. I'm going from 15 volts to 12 volts. If you're using, say, a 3 volt LED, you're going to have to use a bigger resistor, and you're going to have to do your own calculations, etc., etc. So I could wire these resistors in line with the LED, but it's a lot of faffing about, and it'll be covered in shrink wrap, so if anything happens to it, I can't get to it, not very easily. And I thought, wouldn't it be nice to put them all in one place on a board? So we're going to do that in a bit, and it'll be the first circuit board that I've ever made. So it's going to be interesting. I did say that not all of the LEDs are going to be powered by the points, and there's a reason for that. A point only has two roads unless it's a three-way point, but then you treat it as 2 points. But it has two roads, so therefore it can light up one of two LEDs. Therefore, this LED here, for example, is before the point, and therefore this would always be on. It would always be green, because power will be coming down this track to the point. It then depends which way the point is switched as to whether this one lights up or this one lights up. So this one, and that one, and that one. Now that one and that one are between, they're actually the slip itself. It's the center part of the slip. But to make this panel sort of understandable and able to use it, I need to have a point motor at each end of the slip. So I put an LED in the middle so that there wasn't just a blank piece of track there. So from what I've worked out so far, that LED, that one, and that one, and probably that one, I'm going to leave on all the time. So if there's power to the DC bus, those LEDs are on. And then as points change, other LEDs will light up and go out. So I'm going to make two boards. I'm going to make one with the resistors on for all the point driven LEDs. So there's going to be 12 points, and therefore there'll be 24-ish LEDs. Now the LED, as per the drawing here, the two LEDs can share the same resistor. So I need 12 resistors soldered to one of these boards with the ability to connect my cables at both sides of the board. I'm then going to make another board purely for the resistors powering the LEDs that are permanently on. I hope that all made sense. It's quite difficult to explain. Now I've done a couple of experiments, so I'll show you those. So if I plug in my NCE power cap, I've wired 4 LEDs here through one resistor, and I thought I'd give it a go because I wasn't sure if one resistor could cope with multiple LEDs. So if I plug this in, let me give it a second to fire up. The LEDs come on, and I had these running earlier on for probably a good hour just to see if anything got hot, if the resistor got hot or these got, but nothing, everything's absolutely fine. So on my individual little board, I can solder on one resistor, the ability to connect wires at either end, maybe even solder them to the board, and run 4 or 5 LEDs off it for those ones that are permanently on. And then for the ones that are switched with the point motors, build a separate board with an individual resistor for each wire, because they switch individually, obviously. Now, on the point of them switching individually, yes, I know I could wire up some of these points so that they switch together. But I think to start with, I'm going to get them all operating individually. And then as I get familiar with the layout and operating it and things, I can make those changes later. I just don't want to complicate things too much at the beginning. Right, I'm going to show you another little experiment I did with these LEDs, which will show exactly how they work when wired up by the drawing from DCC Concepts, only in DC, because in DC I can switch the polarity to show you. Okay, so I've took 2 of these LEDs And to show you how the wiring works, basically we take a live and a neutral from one of each. So I've got the live for one and the neutral of another one. And I'm going to put those together. And let's pretend that they were soldered or whatever to the resistor. I don't actually need to put a resistor in this line now because I'm only using a 12 volt transformer and a 12 volt LED. If this was DCC, it would be something like 15 volts, and therefore I would have to use a resistor. But then we get the other two, black and green, and we would put those in the other side, the neutral. And obviously that one's got to be connected to the live. So what we've got is the live from here going to this LED, and then it goes down the black to the neutral, and then this one works the opposite way round. And as the point motor switches to change the polarity of the frog, then because these are wired to the same terminal, it does the same thing. And by switching the polarity of the feed to these LEDs, depends which one comes on, because they're fitted with a diode, and a diode only allows power one way. So if I now imagine that, so my track power's on, so my DC, just pretend that this is a DCC, it's on at a constant 15 volts. Now with a DCC system, I can't change the polarity of the track. I've wired it in such a way that the back rail is always negative and the front rail is always positive. So I can't change the polarity of the track. So this in effect is acting as a point motor. And that's how it's wired up. So in my control panel, I will be connecting the brown wire from the point motor through a terminal block to the board with all of the resistors on. It will go through a resistor to one set of these wires, and then so one set of these wires will be connected pretty much directly to the end of the resistor, and the other two will go to the DCC bus. So inside the control panel, I'll run the DCC bus inside it and connect them to there. That's how it works. I hope that all made sense. But I thought, you know, this is all new to me, and I've spent a couple of days learning about it and how to wire it up. And I like to test things, I like to try things out. It's not that I don't believe the drawing from DCC Concepts, of course, it's just I like to get my head around it, and once I can understand it, it makes doing things so much easier, like building this control board. So what I'm going to do now is get set up to do some soldering, and we'll build this board with all of these resistors in. Right then, all we need to do this is a soldering iron, some solder, some resistors, and what they call a breadboard or a prototype board, and all this stuff is cheap. You can get this on Amazon or eBay, you know, none of it's very expensive. I think I bought 100 resistors for like, I don't know, 5 or 6 quid. And I'm sure you could get them cheaper than that as well. So all I've done with that one that we used earlier to test the DCC and the LEDs is get a resistor, bend the wires slightly, poke it through 2 holes of the board. Now I do want to get them all the right way round. Not the right way, the same way, just so it looks nice. I'm not an expert in this, but I don't think putting the resistor either way around makes that much difference. Not for what we're doing here. So you can see there's two on there now, and then on the back I bend the wires out, and that's because one, it holds it in place, but two, when I've soldered these joints on this side, I want to bend one of these wires back through another hole so that I can then solder my circuit wires to them, and then the other one will stay on this side of the board. And I've bought a very similar looking thing to this, but with pegs that come off the bottom that will push through the holes in the prototype board, and then I can solder those pegs to the individual wires, and that means I can have a screw connection, a connection electrically that I can take apart for the LEDs going up to the control panel surface. Because when I make the final version of the plan with the lights and things, I'm going to have to take all the LEDs out and put them back in. So I don't want to solder that connection, I want it to be a screw or clamp connection. So I'm going to put that one in, I think, now. So my soldering iron has switched itself off. That's good, isn't it? So we'll put another one of these in while it warms up. You just grab one, pull it out. Bend the two little wires. Now I'm leaving a row between these resistors, just to give me space, and the pitch of the holes in this board is 2.54 millimeters. So if you're going to buy board and things to go on it, you just need to get things that are the same pitch. So that one and that one, no, that one. Yeah. Okay, we're up to temperature. So I'll just bend those over. And all I'm trying to do is just solder the capacitor, the resistor in place. It isn't really altering the electrical conductivity of it because the wires are still intact underneath. It's just to hold it down on the board more than anything. So that's that one. That one's wobbling about, so I'll change that. I'm not the world's best solderer by any means, but that will hopefully be okay. And I soldered this one exactly the same and tested it as you saw, so they do seem to be able to take a bit of heat from the soldering iron just to get them put in place. Right, I'm going to get all 12 of these in, and I'll come back to you. Okay, so that's my 12, just check, 1, 2, 3, 4, 5, 6. Yep, 12 resistors soldered to a board. Not the best soldering in the world, but they're stuck to the board. I obviously want to check that every single one of those works now on a DCC power supply through the resistor and lights up an LED. So we'll set the camera up and we'll do that. So these two Wagos are carrying DCC current from the power cab. So I'm just going to connect the negative to the negative. So what I want to do, take that off of there, touch that one, lights up. Because it'd be a real pain to fit this board, wire it all in, and then find that one of the resistors didn't work. So that's fine, every resistor is working on this board. So now all I'm going to do, we'll go with this side, these prongs here, is I'm going to try and bend them back up through the board so that there's a tail sticking out on each one, and then I can solder my wires to those that then go to a similar thing like this. So this, there'll be some wires between the terminals here to there, and this is the bit that plugs in off the wiring loom to the board. So I'm going to poke them through, say 3 holes down. Not 3, might be 4. Either way, I don't know if you can see that on the camera, I end up with a little wire sticking out. That I can solder to. So I've got to work out where I want to put the board and where my connector will be, and it's going to be down here somewhere. So I would think something along those lines, and then I've got to bring all of the LED wires from the control panel, or most of them, down to this terminal block that gets soldered on, and then I've got to link this with brown wires to this or a similar item that will be plugged in and unplugged. So that piece will be screwed to the board, to the control panel. This bit will be on the wires of the wiring loom from the board, and so that would get pushed into there. And these are a real nice fit. I do like these connectors. So I need lots of bits of brown wire. I need 12 pieces of brown wire, and this arrived today. Okay, so I've prepared my wires and the board, all the resistors on. The tail off the resistor that poked up through there, I've now soldered there and there, all the way across. These ones are ready to poke through and solder once I get the connector thing that I've been talking about. But you don't need to see me do that. It's the same thing, you know, you're poking something through the hole and you're soldering it. So all I've got to do now is solder these wires, one on each of these, and that's this little part done. Okay, so that's that piece done. I've got some of the, like, you know, the liquid electrical tape insulator that I'll paint over the cable ends there. These ends I've tinned because I couldn't find any crimps, any ferrules. So I've tinned those and they'll go straight in the terminal block when that arrives. And like I've said, the other end with the little wire sticking out at the moment, they're going to get soldered to a screw connector. But that's all the resistors I need to operate the points or the LEDs that are switched by the points. The other LEDs, I will just make a board with one resistor on it and enough terminals that I can connect, I think it was 4 or 5 LEDs to. So a bit more progress. It all takes time. There is a saying in this hobby, you know, you need to be rich in money or rich in time, or both. A lot of stuff you can make yourself really cheap, like that. I'm sure I could have bought a board pre-assembled with resistors on, but that's not as much fun. So thanks very much for watching. I hope you've enjoyed this one. Not quite so much happening, but it's all an integral part of the control panel, so I thought I'd show you. So if you've enjoyed the video, please give it a thumbs up, and if you haven't subscribed yet and you like this sort of thing, hit the subscribe button, and I'll see you next time.